Okay, now instead of just looking at some algebra functions, let's think about some geometry problems that we might have had. So, and let's say we have a triangle here, and we'll give it a base length of 5, and we'll give it a height of 4. And so the question is, what's the area of this? And we've all done this problem before, right? We know that the area is 1/2 base times height. So we can look at how this can be coded in Python as well. And then we'll take one more problem, and let's say we had a circle, and I'll just give my circle a radius of 6. And given this, maybe I want to say, well, what's the circumference of the circle? So we go back to what we know from geometry, and we know that the circumference is 2 pi times the radius. All right, so these are two more functions that we should all be familiar with, and let's go ahead and take a look at how these would look in Python as well. Okay, so now I am back, and we will look at some of the geometry formulas this time instead. And so if you recall, we had two shapes. I want to do the area of a triangle, and then I also want to do the circumference of a circle. So start out just like before, say the definition. And this time, all right, instead of using something like f or a, we can actually use descriptive names for functions, and we probably ought to in most cases. So I'm going to call my function triangle area. And because my function is more than one word, you're not allowed to have spaces, so I'm going to use a underscore to separate the words, and then make sure these are in all lowercase letters. Doesn't really matter so much right now, but when the code gets more complex, you'll see that that's going to be helpful. And my triangle takes two arguments, two parameters to define the area. It's the base and the height. And so I can make an equation in here that says area equals, and I'll do 1/2 times the base times the height, and then I'll return area. And so if I want to test this out, we go triangle area, A1 equals triangle area, and let's just try a couple out. Let's do the 4 and the 5, like in the example. And why not pick a few more as well? So we'll do area 2 and area 3, and we'll do 14, 7, and 3, 12. And then we can, just to check that it works, say print A1, and then we'll do 2 and 3, and we'll print it out. Right, and A3 is not defined. There we go. Right, so we've got the areas of each of these three triangles. So that was easy enough. Let's look at the circle. And the circle incorporates pi, so that's why I picked this example. So I am going to make another one, def circumference. And circumference, you only need to know one thing to figure it out. It's the radius. Right? If you haven't noticed, I'm always ending with a colon here before I indent. And so the circumference is going to be 2. And now, one thing I could do is I could say, well, let's just do 3.14 because I remember that times the radius, and I'll return the circumference. And this is a complete function, and it will work reasonably well. So try a couple of those, like 6 and 10, print C1, C2. Okay, and we got the answers. But let's suppose, it seems kind of weird in this problem that I had to type pi in myself. So, most programming languages are going to have that constant pi built in somewhere. And so in Python, there is another module that we can import and it's called math. And math has constants such as pi and e built into it. E if you've done stuff with logarithms. And so this is just another program, kind of like we've written here, that's already installed on our computer that has a value for pi, a variable pi entered in it, and we just want to have access to that variable in our own program. So what I'm going to do now that I have imported math, I have access to all the code inside that math module. And if I wrote math.pi, right, so the value is called pi and everything's all lowercase, what this is going to do is give me a value of pi out to a whole bunch more decimal places, and I get more precise answers here. All right, so now let's let the formula start to get a little bit more complex. So suppose I had 2 points, let's say 3, -1, and another point, 14, 5, and I wanted to know the distance between those 2 points. So in this case, we're going to use a formula we probably learned in geometry. It's the distance formula, and it looks like this. So it's the square root of, and it will be x2 minus x1 squared plus y2 minus y1 squared. So still a formula we're all familiar with. We know how to work this out by hand, right? We can plug in that this is the x1, y1, x2, y2, and we could plug it in and simplify this. But one of the things that's different now compared to the previous functions is, one, this is a little bit more complicated down here, so we'll have to be careful with our order of operations when we code this in Python. And, we have a square root, and we have yet to talk about how to do square roots in Python. So you'll see that in this example. So now I'm going to go ahead and take a look at this distance formula and turn this into code. And again, remember this one we picked out because there's a square root in here, which we have not discussed how to do yet. We just know how to do basic operations like add, subtract, multiply, and divide and exponents. So we'll just kind of build this incrementally here. Let me give myself a little bit of room. And okay, so the distance formula, it is going to take 4 arguments. I could do something like this, x1, x2, y1, y2. But I think that's kind of weird because that's not how people think of points. I think it makes more sense to think of, oh yeah, let's give x and y for the first ordered pair, and then x and y for the second ordered pair. So I think that this makes more sense probably as a way to enter the points you're going to find the distance between. And so I'm going to do a colon and hit enter, and d equals. And since I don't know how to do the square root yet, all right, let's just deal with the inner part. And so it's going to be x2 minus x1. And if you remember, you square using double asterisks. And we'll do y2 minus y1. And we'll square that. And so now how do we get the square root of this? What we're going to do is there is a function, again, in the math class called sqrt. That's the square root function. And so I'm just going to write math.sqrt. And then anything in this set of parentheses, and I'll kind of exaggerate it so you can see. So from here to here, right, that gets square rooted. Now I'm kind of looking at this problem thinking, well, maybe it's starting to get confusing with all those parentheses. So sometimes it's worthwhile to go, you know what, let's break this into multiple steps. So this is really the distance squared. And so the distance is going to be, and I'll just use D, is going to be the math.sqrt of the distance squared, and then we'll return D at the end. And I think sometimes when these expressions get complicated, and you have lots of operations and maybe a lot of parentheses especially, It's hard to see how all the parentheses pair up, so breaking things into 2 lines is not a bad idea. And so let's test it out. And we'll say distance. And we'll do -1, negative, or we'll do just same from the example 3, -1, comma 14, comma 5, and we'll print b1. And I'm only going to test this one once just to make the video short, but let's see if it works. Okay. All right, so there we go. That's the distance between those 2 points.